So we've kind of already been doing composition of functions, believe it or not. All right. A composition of functions, what is it? It's just when you have two functions and you plug one function into the other. Okay? So a composition of two functions occurs when one function is plugged into another function or is substituted into another function. Okay. And let's see here. Given f, g are functions, then a composition is denoted as such here. Okay, or those are supposed to be like little open circles there. Okay, so it's not supposed to be like filled in dots. It should be like a little open circle. Okay. But it's like in the middle of the line, I guess you'll say. So it's like you took the multiplication symbol, made it a little bit bigger, and then made it, hollow. That would be what it would be like. Okay. Frog. It kind of looks like that, exactly. Describing some of our mental states this morning, too. Oh.
I don't know this.
Yes? Okay, good.
I remember this too.
Good. Hopefully it is something that you've seen before. This notation may be a little bit, less familiar, but
We did the
that
frog.
is the way. You did? Okay. Well, there you go. Because it is used, and so that's why I want to throw that one at you too, because we could just as easily say f of g of x, g of f of x like that, but I also wanted to show you the other way too, because you might see it either way. Okay? So that's a composition of functions. Okay? It's just a matter of plugging them in to the right thing. Will these two, so we're using the same function here, right? We're using the same function. G, in the first case, we're plugging G into f. In the second case, we're plugging f into G. Right? So it's the same function. Will we get the same result in general when you take a function and plug it in and then switch the plugging there? So in general, right, no, we won't. Okay? There will be cases where that happens. Okay? There will be cases where that happens. But in general, you're not going to get the same thing. They might be close, but not necessarily the same. All right, so let's see here. Let's do an example here. H of x equals x minus 2, and g of x equals x squared minus 4x plus 1. Okay. Given those two options, let's see here. We're going to find, first here, we'll do h of g of x. H of g of x, just like that. All right, which, if you want to kind of make the steps easier, right, I'll just replace g here, and I'll say h then of, what is g of x equal to? It's x squared minus 4x plus 1. So we can just replace the g. So now it's really h of x squared minus 4x plus 1, which is just like something we've seen, in the past when we were talking about evaluating functions and things. All right. And so this x squared minus 4x plus 1 is going to replace that x up there in the h function, and so it's going to be parentheses x squared minus 4x plus 1 minus 2. And then we can go ahead and simplify here, right? So we get x squared minus 4x minus 1. And then there's our final answer. Okay? Simplified, at least. Questions on any of that? Pretty easy. All right, you guys try this one then. All right, so I just did h of g of x. Why don't you all try g of h of x? Okay, so you guys give that one a try. G of h of x. Simplify that as much as you can.
Would that be fog?
That would be ga.
Oh.
Mm-hmm. G-O-H.
Oh no.
-4 times -2 would not be -8. Be careful with that.
Oh.
Remember, this foils out too, so it'd be just x squared and plus 4 over here, but you'll have a middle term there too.
Oh, okay.
You're still working on it, gotcha. What's the matter?
I thought I did it, but it's like not right.
Okay.
Do you like multiply the two together, or do we do what we did?
It's not multiply, it's substituted. So if you need to here, when you come across this notation, okay, consider rewriting it in maybe this format.
I'm completely confused.
Okay, well, I'm going to work through it right now, Jeff, so just follow along here and see if you still have questions, okay? So, g of h of x is what we're trying to find. H plugged into g, and so I'm going to go ahead and replace that h with the x minus 2 quantity that it's equal to there. So it's really g of x minus 2. Okay, and then we'll just plug that x minus 2 into g. So wherever there's an x in g, so it'll be the quantity x minus 2 squared minus 4 times the quantity x minus 2 plus 1. Okay. So we're taking that function g, that named object that's defined above. G, when we apply it to x, takes our x and squares it, subtracts 4 times that x and adds 1. Here, we're going to take g and apply it to x minus 2. So it's going to take x minus 2 and square it, subtract 4, multiply by x minus 2. And add 1.
Up to that point, but
And so now we expand it out. So x minus 2 times x minus 2 is going to give us x squared minus 4x plus 4. You got to FOIL it out.
oh, I see.
Right? Okay? And then distribute the negative 4, it'll be minus 4x, but then plus 8, and then plus 1. You can combine all your terms together. X squared minus 8x plus 13 as your final answer there. Okay?
So it's x squared minus 4x plus 4 minus 4x plus 8 plus 1.
Yes, and then combine like terms. Good.
Okay.
All right, moving on here. Let's try another one. All right. F of x equals the square root of x squared plus 9. I'm off the screen. There we go. Okay. F of x equals the square root of the quantity x squared plus 9. G of x equals x squared plus 2. Okay. And I want us to find g of f of 2. G of f of 2. Okay. What's that? What do I mean?
Like you have F2. Normally you have F of X is the 2
Yes.
you're getting.
So g of f of 2, we're going to evaluate that now. Instead of g of f of x, we're going to evaluate g of f of 2. Okay.
So just plug in the 2 wherever the x would be.
That's right. Just plug in the 2. Okay. So you have you have two options here. I would say like two kind of main paths you could follow. Option 1, you could do exactly what we did here previously. Okay, and just find g of f of x, and then plug in 2. Right. So you can kind of do what we did here, like compose the functions, then plug in 2 at the end. Or you could take it a step at a time and say, all right, well, since I got to find g of f of 2, let's kind of follow order of operations here. I'll do what's inside the parentheses first. What is f of 2? Well, what will f of 2 be? F of 2 will be what?
2 squared plus 9. That's 4 plus 9. That's
13, right?
13. The square root of 13.
Yep, so square root of 13. Let me simplify there, right? But we're not interested in f of 2, finally, right? We're not done yet. We want to find g of f of 2. But since we know that f of 2 is root 13, finding g of f of 2 is equivalent, okay, is akin to finding
So that's 13 plus 2.
g of the square root of 13, which, right, is equal to, then when you plug it in,
That's just
root
15.
13 squared plus 2, which is then, 13 plus 2, which is then 15. Okay, so there's your final answer. Okay. So because we now have a way to simplify the original function first, right, we have that inner function f of 2, we can find that, we can simplify it, and then plug it into g. You can choose to do it that way. Or again, like I said, you can find g of f of x, and then simplify that, and then plug in the, the 2 at the very end. Yeah.
Will the test be multiple choice?
The test will have multiple choice questions. Yes, but not all multiple choice, no.
I mean, how many?
I can let you know later, but I'll be happy to let you know that, yeah. I think I don't want to say it's under half I will be multiple choice. Up to half will be multiple choice. You prefer multiple choice?
Yes.
See, I think multiple choice, it's really hard for me to I don't really give partial credit on multiple choice, which
No.
ends up then, if you get a multiple choice question wrong, it can count like 5% gone if you miss it.
I know.
Whereas with non-multiple choice, you get
But
partial
I
credit.
rarely
So.
miss multiple choices because it catches the mistakes.
Sometimes, but sometimes it has you, so like my multiple choice, of course, the way they're written, the correct answer's there, obviously, but then my other answers, they're not like random answers, they're like, these are answers you get if you do typical mistakes. So if you do a typical mistake and you still see your answer, you might still be wrong, which,
Maybe I wouldn't do better on your multiple choice. I know that I did very well on the SAT multiple choice.
Well, good, and maybe you would, because there's definitely, there's more strategies you can employ with with multiple choice than you can with non-multiple choice.
Is your
Okay.
test review packet pretty similar to your tests?
I would say so. The test review is like similar in the sense that it covers all of the skills necessary that you need to know, but you also want to make sure you like understand things too, like really understand some of the concepts and things like that. Not just like, so in other words, not just what you're supposed to do, but why you're doing it too, in a sense. If that makes some sense there, you know, that's all. So, yeah, and I can maybe give you a better example of that when we get to the actual review and stuff. All right, this is for y'all to try here. M of x is x squared minus 4. Sorry, I was at the fair yesterday, so picked up some of the lingo there. All right, so m of x equals x squared minus 4. N of x equals 2x plus 1. I want you to find m of n of 3. Okay, so find m of n of 3. And then second, if p of x is equal to x plus 3, I want you to find m of n of p of x. Okay? That's it. Those two questions. Okay. So take what you know about compositions, right? Well, the first one is just review what we just did. But take what you know about compositions and just expand it a little bit for that second one. Okay? Of course, if you're not sure, you want to ask someone or look at someone else's paper, that's fine too. For now. Okay? Give those two a try. See what you can come up with. I'll come around and help if you feel like you're drowning. Your notation's a little funky, but so far so good. Yes.
So we like do like then and put in things that can tell like what to do next. Like this.
So, yes. What should you plug into what else?
And like do this one.
Well, careful. This is x. There's no numbers here, so you're going to end up with a function at the end, not like a value. You see what I'm saying? Because like there's no number. It's an x. If it was like a 3, then you could like do it. You can get guys. So. this is a 2. So then when you plug the x plus 3 in, it changes your entire answer, and you'd have to rework the whole problem. That's all. So I mean, you know, but yeah, that would be it. So it would be 2 times x plus 3. So you have 6 or 2x plus 6 or 2x plus 7. You have to add it. But anyway, yeah, we'll go over here. Yeah. Yep. Yes, Chip.
So I'm confused about the order of operations here. Would you just do these 2 first, or that?
Good question. So according to PEMDAS, right? Parentheses, and then next is x squared first.
Square first, and then I thought this distributing might be counted as part of the p.
Oh, it's not in the front. It's got to be inside the parentheses.
Inside of it.
Yes,
Got it.
exactly.
So not just working with parentheses, but actually
Correct.
inside of the
Correct, exactly. Grouped together inside parentheses. Yep. Okay. So, m of n of 3, you should have gotten 45. Okay, does anyone need to see that one done? First piece, 45. We're all good with that? Okay. N of 3 is going to be 7, and then you plug 7 in for the x there. 7 squared is 49, minus 4 would be 45. Okay? And then for this last one here, all right, so m of n of p of x, so m of n of p of x we know is x plus 3, so I'm going to replace the p of x with the x plus 3.
3. Oh, I thought we were just doing the m of n of x.
M of n of p of x. So if you have your m of n of x, you can plug x plus 3 in where you have those things then. Oh, this right here? Nope, just 45. You're plugging 3 in for the x values there. So if you just plug in 3, if you did m of n of x, you should just be able to plug in 3 and be good.
So that's 2 times 3 squared.
And then we'll plug in x plus 3 into the n here. So it'll be m, and that's going to be 2x plus 6 plus 1, so 2x plus 7, like that. That is an m. You need to be pretty careful there.
Right.
And then 2x plus 7 plugged in there. So 2x plus 7 squared minus 4, okay? And the biggest thing I saw here is people forgot to FOIL out that 2x plus 7, you know? And it's something that you would probably get right if you just had like this thrown at you randomly, but then with all the other stuff you had to keep track of or whatever, you know, you maybe forget, which happens, you know, having to keep track of all the different little intricacies of this problem here. So 7 times 2 is 14 plus another 14, so 28. And then 49 minus 4, so 45. So 4x squared plus 28x plus 45 is your final answer there. Okay? Questions on any of that? Okay? So,
46.
there it is.
9.
All right?
Yeah, that's 45.
Okay, good. You agree.
So yeah, I got the first one right.
So say we all.
I didn't even finish the second one.
Okay. So you can check and do the second one right now if you want to. Any questions on, we're done with composition. That's all we're going to do today on that. I do want to give you an opportunity to ask any further questions on piecewise functions. Any further questions on piecewise functions?
I was looking at a general question about the test.
Okay, about the test.
So we'll have a graph to like write the equation of it. We'll have to do that.
Potentially.
Okay.
And then potentially you'll be given the equation.
More practice.
And that's right, the graph. So I would say there should be some more on the paper there. There will be some more on the review too.
Okay.
But if you would like some more in between those times, I can look up something and find it for you. Maybe you could just
Will we
practice.
be given any scratch graph paper
Of course.
and or a calculator?
Of course.
Okay.
Either one, you know, if you don't have a calculator, then definitely paper and otherwise.
Is there gonna be like a non-calc and calc active?
Correct.
Okay.
Yes. Yes. It'll be both calculator active and non-calculator active. Yes.
So with Mr. Walker's thing,
Uh-huh.
he would give us the basic calculators for the non-calculator thing, which is we're allowed to use our graphing.
I see what you're saying.
So
Speaking-
it's not that.
It's not that correct.
Speaking
Yeah.
of which,
Unless people have like an accommodation or something like that.
speaking of which, we're working on the whole calculator situation.